Hi, so the chemical I'm presenting is called aconitine. What is aconitine? Aconitine is a main toxic component present in plants such as aconitum carmichaeli, radix aconiti, quincephae, and aconite. It mainly excites the vagus nerves and damages the surrounding nerves. The symptoms of poisoning are mainly demonstrated by nervous system and circulatory system, followed by digestive system symptoms. So why I chose aconitine? So I chose aconitine as an organic compound I study because many traditional Chinese medicines contains chemical aconitine, but we also know that 3 to 4 milligram of aconitine can be fatal, just like arsenic can treat leukemia. Aconitine is contained in many herbal medicines for healing and saving lives. It will be interesting to know the chemical formula and various properties of aconitine. The scientific investigation skills. So aconitine is a neurotoxin chemical, which means it is destructive to the nervous tissues. So it is fatal if swallowed or inhaled, danger acute toxicity. So as I said, the main damages to the circulatory system and digestive systems. So what do you do after if you are poisoned? So oral extended use medicine. So medicinal wine containing aconite should be stopped immediately. So you should remove person to fresh air if inhaled. Do not induce vomiting. Rinse mouth with water if it was ingested. After skin contact, remove clothing and rinse thoroughly. After eye contact, rinse immediately with water. So the structures and properties of the aconitine. So the molecular formula, as you said, it's carbon 34, hydrogen 47, nitrogen and oxygen 11. The molar mass of this chemical is 645.7 gram per mole. So the physical properties of the of aconitine, it's a white solid object, white solid chemical. Its boiling point is about 657.2 degrees Celsius to 777.2 degrees Celsius. Melting point is about 203 degrees Celsius to 204 degrees Celsius. So the density of aconitine is about 1.3 to 1.5 gram per centimeter per second cubed. So it is barely soluble in water, but very soluble in organic compound. So for example, it's soluble in water is 0.3 milligram per milliliter. The soluble in denser ethanol is 35 milligram per milliliter. The chemical properties is first is stable under the prescribed storage condition. It is incompatible with strong oxidizing agent and strong alkalis. So it has 3 hydrogen bond donors and 12 hydrogen bond acceptors. In organic chemistry, first is IUPAC naming. It's over here. It's really long. It's made of really many functional groups, and so the general classification of the chemical is first it's nordoterpenoid alkaloids or aconitum alkaloids. For the functional groups, first there's hydroxyl groups. Over here. There's also carboxyl groups, and there's also benzoate group. And amide group. And also there's S-toxyl group. For the thermochemistry and chemical kinetics, so I chose a reaction of hydrolysis of the aconitine. So to use aconitine in medicines to form a aconitine which has less toxicity, the hydrolysis needs to be done. So the acetic acid and benzoic acid are the toxic components that are reduced when adding heat and water to aconitine. So at pH of 5.21, 6.95, and 8.01, the activation energy of the first and second reaction. So for the first reaction, which is aconitine to benzoaconite, for the pH of 5.21, it's about 104 kJ per mole, per mole. And for the pH, if it has pH of 6.95, it's about 94.1 kJ per mole. And if its pH is 8.01, the activation energy is about 73.9 kilojoule per mole. So for the second reaction, which is benzooctane to aconite, so for the 5.21, 6.94, and 8.01, the activation energy is 104.9 kJ per mole, 83.8 kJ per mole, and 57.3 kJ per mole. So under certain pH condition, aconitine hydrolysis into a series of two first-order reactions. The reaction is catalyzed by hydroxide ions. The rate constant of the two-step hydrolysis reaction increases with the decrease of the pH value of the medium, and the rate constant have a parabolic relationship with the pH. In alkaline solution, the two-step reaction rate constants gradually decrease with the increasing ionic strength, and the reaction exhibits a strong kinetic salt effect. In neutral and acidic solution, the salt effect is weak. For the equilibrium unit, so as I said, I chose a hydrolysis reaction of the aconitine to aconite. So for the hydrolysis of ester bonding, it's considered as a equilibrium process. The reverse process is called the esterification. So as we know from the previous previous diagram, as we see, the first reaction they took off the acetic acid, which is over here. And the second reaction, the benzoic acid is being hydrolyzed. So we know that acetic acid CH3COOH and benzoic acid C6H5COOH are both ester bondings. So in most cases, the addition of acyl oxygen bond breaking in the reverse reaction of acid catalyzes esterification. In the process of acid catalysis, carbonyl oxygen atoms are protonated first, which enhances the positive electricity of carbon, thus improving its ability to accept the attack of nucleophiles. Also, water molecules attack carbon, forming carboxylic acid and alcohols through addition and elimination. Carboxylic acid and alcohol can be combined to form ester again. So the hydrolysis of ester catalyzes by assay cannot be performed to the end. The forward reaction is endothermic, and increasing temperature during hydrolysis will favor the formation of the product. And the electrochemistry, the redox, for the potassium permanganate is the most promising oxidizing agent. So oxidation of this alkalides involving the type of reagent and the nitrogen is complicated and gives variable result depending on reaction conditions. So the oxidation of aconitine with potassium permanganate in acetone containing acetic acid produced several neutral compounds and formed the mixture. Oxanidine was isolated in 20% yield. So the ending. So it's a little research. Some studies believe that the toxicity of benzoaconitine bases generated by hydrolysis can be reduced to about 1 over 200 of aconitine. But considering that aconitine is a very toxic substance, 1 over 200 is still toxic, not too low. According to the lethal dose of aconitine, 3 milligram. It's like it's 200 times. It's 600 milligram. And usually the lethal dose of potassium cyanide is between 50 to 250 milligram, and the lethal dose of arsenic is about 70 to 180 milligram. So more importantly, during the processing, the hydrolysis of diester alkaloids is now complete, and there's still certain amount of residual in the medicine materials after processing. So it's still not healthy to consume medicines containing aconitine. Thank you.